Good morning, everyone, and welcome to Bite Size Buhl. My name's Mike, and I'm an educator with the Buhl Planetarium at Carnegie Science Center. And today, I'd like to invite you to join me on a mission to planet Earth. Today, we are celebrating Earth Week with a mission to learn all about the amazing science we're learning from orbit to take the pulse of our own planet. The more we observe from space, the better the information we have to conserve our home planet Earth. So we're going to get started with a journey around our beautiful blue marble. And I'm using a software called Digistar, which we use on site in our Buhl Planetarium. And I'm going to kick things off by flying us to the start of our story today. We're going to take kind of a whirlwind tour of some of my favorite places on planet Earth, and I hope you enjoy the ride. All right, our first stop is to the western United States, to the Sierra Nevada mountains in central California. We are heading into Yosemite Valley. And I should mention I'm actually flying using an Xbox controller, which is way too much fun. But we're going to zoom into Yosemite Valley, and I picked this to kick things off for a couple reasons. The geology is amazing. This is a valley that was carved out by glaciers, by slow-moving frozen water during the last ice age. It's a testament to the power of those glaciers, but also the staying power of this tremendous granite. We have these sort of soaring, vertical, sheer rock faces here with names like Half Dome and El Capitan, the Chief, soaring thousands of feet into the air. At the base of the valley, there are more than 400 species of grass and wildflowers that bloom here. And Yosemite Valley is also home to giant sequoias, the largest living thing on planet Earth. I'm going to see if I can take us down for a deeper view. There we can see the sheer vertical face of these amazing granite cliffs. I picked Yosemite Valley as our starting point because it was this valley, first protected by President Abraham Lincoln, that was the inspiration for our National Park Service, sometimes referred to as America's best idea. President Teddy Roosevelt took a legendary camping trip here with the naturalist John Muir, and that trip and the conversations that had inspired the creation of Yosemite National Park, its expansion, and the creation of the entire national park system. So this is really an appropriate way to kick things off by thinking about Earth's natural beauty and how we can protect and preserve it. But this is only our first stop today. We're going to visit lots of fun locations. So we're going to head back to space for another orbital view of our blue marble. And our next stop is Wyoming. We are going to zoom down in with another satellite view to another national park. This time we are heading to Yellowstone National Park. Now, this is over top of an ancient, long-dormant supervolcano. It's home to some amazing geothermal wonders, probably most famously the geyser Old Faithful. But we're going to zoom in on another wonder, a colorful hot spring. And we'll let the data load in here for just a moment here. As we situate ourselves in the proper location, I'm going to take us back down through the clouds. All right, there we go. Our destination is the Grand Prismatic Spring. This is kind of a living thermometer. What we're looking at around the edge of that spring is life, microbial life. This is a hot spring. It's incredibly deep. It's as deep as a 10-story building. So over 120 feet deep there's a crack in the earth and extremely hot water comes up and is exposed at the surface. Now, if you have just a glass of water, that's clear, but if you have a deep enough column of water, like an ocean or, say, a hot spring, the true intrinsic blue color of water will come out. And because this is such a deep column of water, we see that true rich blue color. But all of the other colors we see around the edge are due to bacteria. It's too hot in the center for anything to live, but that ring around the edge are different species of bacteria. And the farther we get from the center, the cooler it gets, and so different species take over, and they show us different colors. We get this beautiful rainbow effect, this beautiful prism of life. These are called extremophiles, these life forms. They can survive in even the most extreme conditions. And as we study locations like this on Earth, that really helps us even think about exoplanets that we're exploring in space. Very harsh conditions and what kinds of life might be hardy and resilient enough to live on those exoplanets. A heat-stable enzyme from Yellowstone bacteria has even been useful on Earth in cancer research and genetic testing. So this is a pretty exciting place here. Grand Prismatic Spring. It's kind of a living thermometer. All right, we're going to head back into space, and our next destination is Alaska. We're going to zoom on in to the tallest mountain in North America. And here we can see the sunset. I'm going to move the sun. That's a fun power to have. So we can get a better view of the terrain here. Oh, let's bring the sun back a little bit. There we go. All right. As I said, this is the tallest peak in North America, piercing the sky at over 20,000 feet. This is Denali, a colossal mountain named by the native Koyukon people who live just north of the mountain. The word Denali means the tall one. And it's covered in glaciers, large areas of thick ice that stay frozen from year to year, and they slowly flow over the land. You can see from this view this kind of glacial frozen rivers. What's really exciting is some breaking news. In March, it was observed that a glacier on the north side of the mountain is now on the move. There's a glacial surge. I'll see if I can spin us around for a view of the north side of Denali so we can take a look at some of that glacial action happening. Because it's on the move now, hasn't really had any activity in 60 years or so, but now it's moving up to 60 feet per day. It's known as Muldrow Glacier. And scientists are tracking this glacier right now in a number of ways. So there's another nice high view of these frozen rivers. As we come down, we're going to see if we can spin around to the north side of Denali. You'll see the summit of Denali on the left side of your screen. And there we go. Now we're coming in from the north. So let's take a look at those glaciers on the north. Scientists are tracking the movement of this glacial action, and there's lots of different cool ways that we're doing that. Aerial surveys that give us data like what we see here, but also GPS units that are on the glacier itself, time-lapse cameras that are actually set up, and even a sound station. Just imagine what all this crackling and popping ice sounds like as it's on the move. There's a sound station there to try to track what that's like. So I can't wait to both see and hear the data from that. The actual glacier that we're talking about, you might be able to see the tallest peak right there in view, and you can make out the path of that frozen river as it was coming down off the mountain, kind of on the right side of your screen there. That's Muldrow Glacier, which we're taking a look at right now. Well, this is a tour of the entire world, so we're going to head back up into space. Bid Denali farewell, and we're going to head to the other side of the planet, to the nation of Morocco. We're coming over to the night side of the Western Sahara Desert in Africa. And again, we're going to bring the sun into view. There we go. Much better. And we're going to continue our flight down into the sun-kissed sands of the Sahara Desert. All right. Near the top of your screen, you might be able to see a people-made object. A rather large one. So you can see a town here. Where's Zizat? But above that, we have the Nuar Power Station, and that's our destination. As you might imagine, the desert is a great place to harness solar energy, and Morocco has a goal of harnessing 40% of its electrical needs from solar power in the near future. This power station has some photovoltaic cells, like you might be familiar with, that capture electricity, just making it directly from sunlight. But here at the top is a concentrated solar array. These are all mirrors. And these mirrors all encircle this central tower. Sunlight is focused to the top of that tower. We heat up molten salt to around 1,000 degrees. And that very hot salt can be stored. The heat from that can be used to make steam. And that can be used to power turbines to make electricity, so it can work both day and night to provide energy needs. Now, this power station is huge. Just for some perspective, it's over 6,000 acres. You could fit 15 downtown Pittsburghs inside this power station. This is the largest concentrated solar array in the world. All right, while we're in Africa, we're going to take a look at something else that people built, just a little older here. You can see the Mediterranean Sea to the north, and in stark contrast to the Sahara, you can see the Nile River flowing through Egypt and south. The Nile actually flows north to the Mediterranean Sea, and at the top you can see the river delta. The Nile leaves behind lots of silt as it flows toward the Mediterranean. It irrigates the soil, and so we have that lush strip of land around it that's supported Egyptian civilization since ancient times, but even now 95% of Egyptians live within just a few miles of the Nile River. We're going to descend into Cairo for a moment to take a look. That amazing contrast. You can see the river flowing, that fertile swath of land, and just beyond it, the desert. And we're flying right over top of the Great Pyramids on the Giza Plateau. All right. For our next stop, again, while we are in Africa, I thought I'd point out an inland delta known as the Okavango Delta. And the Okavango is really interesting because it's inland. It's not connected to an ocean or anything like that, but we'll point that out. It's a site of amazing biodiversity supporting lots of cool wildlife right here. And we'll pan out a little bit. You can see it on the right of your screen. Okay. While we're on this side of the globe, let's head north for a moment. To Italy. You can see Italy's boot. And we are zooming in on a city that is bisected by a grand canal. We are, of course, looking at the city of Venice. That beautiful red architecture. I picked Venice because it's striking. You can just see that beauty from space. And it's also from Venice that Galileo did some of his first observations from St. Mark's Bell Tower, looking up at Jupiter and Saturn. That was one of the sites where he first started exploring those planets and learning about them, and that changed our entire view of the universe. And stopping in Venice, we'll kick off a little tour of some of my favorite observatories around the world. We are going to head back into space and spin around to South America. On the right, you see the great Amazon rainforest. But on the left are the Andes Mountains. And we are heading to the nation of Chile. And we're going to head to the high Atacama Desert in Chile. High above the clouds. There's very little moisture in the air here. Very few clouds. It's a great place to build an observatory. And this is where we will find ALMA. That's an acronym. It stands for the Atacama Large Millimeter and Submillimeter Array. Well, what does that mean? Well, this is an observatory that basically looks at light in wavelengths of about 1 millimeter. So these wavelengths are too long for our eyes to see, but it's kind of right on the cusp between infrared and radio waves, these millimeter-long waves. And honing in on those wavelengths of light lets us peer out to some of the most distant ancient galaxies in the universe, and even look around young stars for planets that are still forming. Let's zoom in and take a look at this observatory. It's quite different from what you might expect. I know the first time I learned about ALMA, I was surprised. ALMA is not one telescope or a series of telescopes in the traditional sense. It's a team of antenna dishes that all work together, kind of to team up and form one big super telescope. It's kind of the Power Rangers of telescopes, if you will, or the Voltron of telescopes. There are 66 dishes on this desert plateau, and they can all be spaced out to effectively work together as one giant virtual dish. And those dishes can be moved around too. That's pretty awesome. The dishes can be moved around. They can be packed very close together when we need. They can also be spaced apart. It ranges across spans around 10 miles wide. You can imagine how much work goes into moving these gigantic dishes around. ALMA was part of the Event Horizon Telescope. Telescopes around the world teaming up to form one big virtual dish, essentially the size of the Earth, to peer out and give us the first direct image of a black hole just a couple of years ago. All right. And our next stop will take us back to the other side of the planet. We're heading to the Pyrenees Mountains now. You can see Spain and France on your screen, maybe Italy off to the right, and northern Africa at the bottom of your screen. We're heading right between Spain and France into the Pyrenees Mountains. Another perfect space to be high above the clouds for unfettered view of the cosmos. And we're heading in to a region known as Pic du Midi. It's this mighty mountain fortress of science. It's high atop a mountain peak, 9,000 feet up, and it has to be accessed by a cable car. I actually had the good fortune to ride that cable car to the top of this mountain once, but I can't even imagine in the early 1900s all the effort that went into building this observatory before there was a cable car, and this summit had to be scaled. From high atop this mountain in the 1960s, NASA installed a telescope to map the moon to prepare for the Apollo missions. And from high atop the mountains, we've looked out into space to learn about the sun's corona, to measure our distance to the moon with a laser, to discover minor planets, but also to learn about Earth's own atmosphere and Earth's ozone. Pic du Midi. And that's actually a great place, speaking of the ozone, for me to share some data that's come to us from Earth-orbiting satellites. And the great work of NASA Earth Science and NOAA, the National Oceanic and Atmospheric Administration, in taking the pulse of our home planet. So we're going to head back into orbit, to a nice high orbit around the Earth, and we're going to overlay some data sets here to wrap things up. So we're going to see things now in representational colors. The colors that you'll see represent data, and space artists take all of this data and they assign it colors so that we can understand what we're looking at. Our first data set is accumulated precipitation. So we're going to take a look at that overlaid on our planet Earth. We'll zoom back in here. This is from a NOAA global forecast system. You can see an accumulation over a 3-hour period. Wherever you see light blue, there's not so much precipitation. Where it gets bright green or even white, those are heavier amounts. So we're tracking things over the short term, just immediate weather over hours, days, or weeks. But we're also tracking our climate over time, looking at the same space over a long period of time and how that changes. So for our next data set, we are going to actually spin down to Antarctica. Down at the south pole of our planet. Now we're going to zoom in. Actually, that's an amazing view on our way, though. On the night side of Earth, you can see that accumulated precipitation there, that rainfall. All right. Well, we're coming in over Antarctica. I'm going to move the sun so we have a great view of that continent. We're going to move the sun the other way. It's a lot of power. Here we are. Let's zoom back in over the continent of Antarctica. We'll come to a quick stop out here in space. Move the sun again. All right. We see half the Earth in daylight, the other half at night here from our South Pole. And we're going to overlay some data about our ozone. So our ozone is like sunscreen for the entire planet, right? It protects us from ultraviolet radiation. In this case, the colors that space artists chose help us understand how thick the ozone is. Wherever it's blue, it's a thicker ozone, but wherever we saw that red, the ozone is thinner. When we talk about the ozone hole, what we're really talking about is seasonal thinning of the ozone, especially at the poles and at Antarctica. But the great news is that from data we gathered from space, we've been able to make changes in our refrigerants, even our hair products and other chemicals, so that we are starting to see that ozone recovering over time. Those O3 molecules and that sunscreen blanket around our planet that protects all life, including human life. All right. Well, we're going to head now to the Atlantic Ocean. And we'll spin around for a little more good news, because that's the power of space-based observations. We get that information, and that helps us make informed decisions to take care of our planet. This next one is going to go from a global story to kind of an individual story about one animal. All right, we are going to stop again, though. We're over North America. And we're going to load up a different data set here. Okay. So the North American coast here, the East Coast is in night, but I'm going to zoom us in here. What we're tracking now is one sea turtle. This sea turtle was rescued. That line you see on the right side of your screen there. It was rescued in Chesapeake Bay. It had a broken flipper, probably from a boating accident. But it was rescued by the Virginia Aquarium, rehabilitated and outfitted with a satellite tag. And the data we just looked at is where that turtle, it was a teenage turtle named Delta, and where she went for the next 9 months. So we're able to even track the behavior of one animal from space. Now, in addition to tracking an individual animal, we can look at things on a global scale. We are tracking the health of our oceans as climate change makes them more acidic. Carbon dioxide from burning fossil fuels absorbed into our oceans can affect the health of our coral reefs. But tracking that has helped lead to new research in finding the hardiest strains of coral, trying to grow those and seed those in other areas to rehabilitate the health of reef systems around the world. We're tracking sea ice. We're tracking global temperatures around the world. And the more data we get, the more we can make great decisions to take care of the health of our home planet. And that's the final data set I'd want to share with you today, is a quick view of all of the satellites in Earth orbit right now, giving us that data. There's a team of satellites constantly in orbit around us right now, taking the pulse of our home planet. And future careers that are very important in taking that data and translating it, visualizing it for us on our beautiful blue marble. It's been said that Earth is a spaceship, and we are its passengers. And by exploring Earth from space, as its crew, we're getting the best data we can to help take care of our planet here on the ground. So thank you for joining me for our special Earth Week celebration of the best planet of all, planet Earth. Stay tuned for more editions of Bite Size Buhl. We'll be back again next Thursday. And stick with us on Carnegie Science Center's Facebook page for more Earth Week activities in the days ahead. Happy Earth Week, everybody. Take care.